That's part B, so here's part C. Now in part C, we want the point on the y-axis where it's going to be equal to 0. So instead of putting the particle here, I'm going to arbitrarily put it right here. So we're looking at a point right here. And we need the distance from each of these charges to that point for the potential. So we'll call the distance from on the y-axis, from there to there, we'll just call that y. And we know the distance in the x-axis from here to here is going to be 0, whereas the distance on the x-axis from here to here we already have is 1.6. So the distance from here to here for the pink charge is going to be just y, whereas the distance from him is we need to take a right angle triangle, and so we need using Pythagoras' theorem, we use the square root of this distance squared plus this distance squared. So let me write it out. And so we take the potential at this point C, it's going to be applying this formula here, using the Pythagoras' theorem, or using this equation here for three-dimensional Cartesian coordinates. We have the k times 2 micro over square root of y squared, because the distance from here to here is just y. And then, whereas here, the distance in the x direction is 1.6, and the distance in the y direction is y, so square root of 1.6 plus squared plus y squared. And we know that's all going to equal 0, because that's what the question's asking. At what point is that potential going to be equal 0? And these micros and k's are going to cancel out. So now you're going to need to square both sides, but the way it's going to work out is that you won't have to do a quadratic, because you're not going to have any y terms. You're only going to have y squareds and constant terms. So it's going to work out nice. And the answer you're going to get after doing some math is going to be basically 0.7 meters. And that is how you do part C. Okay, so that covers the problem and all the questions within it. Now, if you guys want a little bonus, I'm going to show you a 3D model of this situation with these two particles 1.6 meters apart. So let's turn to Maple and let's look at our situation here. Okay, where we have the x-axis, the y-axis, and the z-axis. And we see our two particles in 3D space, and we want to know where the potential is going to equal 0, and that is for part B and C. We're asking where the potential is equal to 0. So now let me draw for you this 3D surface, which is a representation of the potential in the xy plane. So this is what the potential would look like. It's this contour where you could visualize it basically if you were to put a particle, let's say right here, what direction would it roll down? Well, that's the direction the electric field pushes it in. And so where does it equal 0? Well, I've drawn this wire mesh. You could see this wire mesh here. And this wire mesh, where it intersects with the potential, that is the place where it equals 0. So you could see there's places on the x-axis where this wire mesh cuts through this contour. And those places on the x-axis, those are the points we found in part B. And the places on the y-axis, if I can rotate this thing properly, let me see. Oh, I'm having some difficulty here. We found this point here on the y-axis and an equal point on the other side. And so these are the points that we found, and this is what it would look like in 3D space. And yeah, so that's this problem. I hope it helps you guys, and if you have any questions, please feel free to ask, and any comments, I would love to have them. My email address is in the description. Thanks a lot, guys.